So I've wanted to do a talk like this for a little while, but what really hit it for me was like over the last 10 days, I was fortunate enough to talk to Kin about what API specs are, to talk on API storytelling with Matt Trask, Kin, and Mike about the history of OpenAPI, Swagger, and where all these things have come from. And then this week on API Storytelling last Friday, it was me, Dev Doshi, Mike, and Kin talking about the future of API specifications. So the last 10 days, like all of this kind of is loaded in my head, and I figured instead of waiting for a conference or a place to submit a paper, I'm just going to record it. I have a computer, I have a camera, I like film, let's just do this. So without further ado, my rendition of the future of API specifications, alternative title, Let's Be Awesome. So I'm going to tell you this before I do it because it's going to mess with you. I'm about to mess with you. Our APIs today, we want them to be evolvable, which means new features can be added without breaking our consumers. We want users to be able to update them on their own pace. We want them to be approachable so you can learn how to use them so that they're easy to understand and so that they're consistent. That's a big part of it. And we also want to make sure that the APIs we build today are useful, that they meet their use cases, and that as much as possible, the API calls the users make or are able to make map pretty closely onto whatever their objective or use case is. Okay, and this is the part where it's like, I'm going to mess with you. So let's swap out our APIs with our API specifications and ask ourselves again, these three things we value in APIs, are they true about our specifications? And we get red flags. They're not. Our API specs, they're not evolvable. There are breaking changes that you can make to an API specification whenever you want to add a new feature. There are many teams out there who are still using Swagger 2.0. And from my conversations with other vendors, what I hear is more users asking for us to support older versions of the spec than to support newer versions of the spec. And that should raise some alarm bells. Also, they're not really that approachable. Most developers out in the world don't use specs. And there's this whole business that Optic and other companies are building around this non-consumption. How do we make it easier for people to use these tools? We also don't really read specs and we don't really think specs. We think in examples. It's easier for us to talk about a JSON body than to understand a schema. And this has made it very difficult for teams to build tools on top of the specs. The fact that there are so many tools is just a testament to how important this stuff is, but it's not like there's a ton of tools out there because they're really easy to work with. And they've got different mileage. Sometimes they're super useful. It really depends on how your team uses it and what you're using it for. One of the most surprising things is that when you look at all the API gateways, people in an ideal place to do OpenAPI validation uniformly across all the clouds, we don't have anything close to standard functionality there. We should have the universal support for validation. And there's a lot of API gateways, not to name names, that don't even do any kind of OpenAPI validation. Or if they do, it is a very limited subset of it. Or teams end up rolling their own, despite the fact that you feel like this is a component that we really should be able to take off the shelf. And it doesn't work that way across languages, across cloud providers. And a lot of teams are using their specs, but have built all of these other tools that are pretty common cases. Like I've seen a lot of companies' attempts at building internal change logs, a lot of companies' attempts at building internal governance tools, a lot of attempts to build their own validation layers. And it feels like, there's just this mismatch between the promise and sort of where we actually are today. So why I bring up these two contrasts, our APIs and our API specifications, is because I think of API specifications as the API for our APIs. They're a meta API in a sense. And I would question everyone in the community, shouldn't we treat them that way? So back to the first conversation that we had with Matt Trask and Kin on our lovely API storytelling podcast. The first decision that was made that sort of set us up for where we are today was this decision to use Swagger, a documentation tool, for everything. So once we have it for docs, let's do it for code generation. Well, we're missing information. Well, let's add some keywords or let's add some extensions. Same for validation. Let's just use it for validation. Let's just use this description of our thing for documentation, for test generation, for change logs to help us understand the data we're seeing in real environments better, to power analytics, to collaborate on our API design, to do API governance. And when we try to mash all these use cases together from this first decision, we run into all kinds of situations that sort of work but don't really work the way that they need to get broad adoption. So design use cases. As we've been getting Optic out into the market, we hear all the time about lifecycle status. If I'm going to do design first, I need to know what part of the spec is designed, what part of the spec is deployed, and what part of the spec is partially implemented. It's super important to be able to understand in this one document the evolution of these different parts of our API, because at any time we want to be able to say, is this thing working the way it's supposed to? And if it's working the way it's supposed to, but there's sort of new stuff and old stuff and changing stuff in there too, you can't really use it as a test artifact anymore. Another huge problem that even large tools who have tried to build OpenAPI workflows have run into is that specs are not natively mergeable or forkable. So we end up with weird conflicts that are line conflicts, but they're actually like API conflicts. So a really good example is if we add a field to a shared schema, that might be used in like 20 different places. In Git, when we try to do a pull request and we see this change, all we see is this one particular change of a single line, but that might be a breaking change in 5 places, might be a compatible change if it's used somewhere else in 10 other places. So we don't really have like the mergeable, forkable thing that you need to even build these workflows successfully. Governance and use cases is huge. Like so many companies talk about this, but a challenge for all governance is that if one day you turn on thousands of rules for your API, a bunch of your APIs aren't going to pass those rules. And if you make changes to make all of your existing APIs compatible and get rid of that noise, you've broken a ton of your consumers. So most teams we talk to talk about this forwards-only governance as one of the reasons why they don't use the existing governance tools. They want to govern what is done going forward, but they understand changing things that already happened in the past is going to be hard. And this happens with code linters too. When I turn on a code linter on a code base I didn't inhabit, it's like a day of work to really go change all that stuff around and make it so that I don't get warnings anymore. But that's fine if it's code. When it's an API contract, when it's an interface between systems, me changing that camel case thing to be snake case is actually going to break people. So we just can't do it. So these noisy governance issues, not really well supported by the first decision. Change logs, I could talk about the difference between change logs and diffs for a long time. But basically, because history isn't a first-class concern in the spec, it's really hard to see when things have changed over time. So it's easy to diff to specs, but it's hard to say what has changed. And this has also led to some of the challenges around using OpenAPI in a design-first way. It's very difficult to understand basically what changes came in what order. So I think, like Git, we need more of a ledger than a flat document. Validation, also very difficult. And another thing that we hear people asking for a lot is when we do see validation errors, and let's say it's not because the API is broken, but because we forgot to update our docs, we want a magic button that lets us turn that diff into a patch, just like we can in Git. And that's basically the reason why tools like Optic exist, because maintaining these specifications at scale is really difficult to do. And then we know that hypermedia, event-driven APIs, GraphQL, gRPC, and all the things that come next don't map cleanly onto HTTP, and they don't match cleanly onto this request message and response message and path paradigm that we've set up in OpenAPI. So I think when you really step back and do what you would do if you were a product designer and try to take stock of the use cases and think about, did we build the right thing? Are we going to be able to move forward with this? The answer is very clearly maybe, but it's leaning towards no. And I think this is really coming down to the fact that complexity was sort of put in the wrong place. A lot of people are building their own tools outside of the specs for things that should actually be inside of the specification. So switching entirely away from API specs themselves to another one of my love and joys, which is documents. Google Drive, Microsoft Word, for a long time have had this built-in understanding of track changes. You could make a suggestion. Imagine having a user suggest some changes to an OpenAPI spec, letting people come in and pile onto that suggestion and recommend other changes, and then eventually say, yep, this is it, we're doing it, and approve that change. I've just described 20 different tools that sort of work that you have to glue together to do that with OpenAPI. But in the real world, we already have tools that were built around change and collaboration sort of on day one that understand the full suite of use cases and accommodate them. So underneath Microsoft Word is a very, very not well architected track changes system. Google Drive's a lot better because they use a CRDT. But basically, this idea that change, since it is the most important thing, should be the core thing, the thing that we're actually modeling. Because it's not part of the spec, we end up building diffing tools and changelog tools around it. But if it's part of the spec, then you move that complexity for the workflow into the abstraction instead of building other abstractions around it. And this is a little controversial, but I think if you have to choose one thing, we don't need to look at the other options. Just choose evolvable. Like, that's the way you want to go. And the way you make something evolvable in this crazy changing world is you invert the question. What stops something from being evolvable? And the thing that stops things from being evolvable is friction. Remove the friction. And I think the friction, the thing that comes from this first choice to use this documentation tool for everything, is this matrix right here. Everything in the world is a Harvard matrix, says the people at Harvard, and it does not actually map cleanly. But in this case, you can make this in a 2x2 matrix. You have human and readable and machine and writable as your rows and columns here. And everything we do to make our specs more human readable makes them less machine readable. Everything we do to make our specs more human writable makes them less machine writable. Or less machine readable. And there's this constant tension. An example that's really simple is references. People don't like repeating themselves. We don't like to write the same schema over and over again. But references by their nature require machines to now be able to resolve all of those references. And it makes it very difficult to build a tool like Optic that would patch a broken API spec or one that's no longer compliant, because you have to know how to walk backward all those references and when the context is right to add the thing or remove them. Another example, one of my least favorite keywords is the read-only and write-only keywords. They are shorthands, but they're ambiguously defined in a lot of ways, and they sort of prevent the user from really thinking about the model that they're building, like precisely, and in the way that I think is most useful. And yes, it makes it more human writable, but at the expense of human readability. I have to go look at this doc, and as a docs viewer, I have to go resolve all this in my head. And as a machine, I have to go understand what this means too. And sometimes that definition may change. And if I'm building a validation tool, the more keywords we have that modify behavior, the more complicated it is. So this conversation doesn't actually manifest as people looking at this grid. What it manifests as are people saying, well, that's a big change for vendors, or ooh, that's a lot to ask of developers, or that's going to break our company's internal tooling. And basically, you end up in this situation where there's too much friction to change, not because people don't want to improve the specs and add new features and make them better, but because you've created basically a topology of this problem where optimizing for any of the constituents hurts the other constituents. And because of that, everything drags to a halt. So how would we change this? How would we think about revisiting some of these first decisions and moving forward in a more evolvable way? Well, spectacle is an idea. And this is a proposal that Dev and I talk about a lot to create a unified, stable foundation for the API tooling space. One that allows the vendors to easily support all of these core use cases, for tool makers to evolve and experiment with new kinds of specifications, and for the space as a whole to deliver more value to developers and their teams. It sounds wishy-washy, so let's break it down into something actionable. Let's make API specs like APIs. What if instead of giant YAML files, specs were basically just APIs that we call? There were different queries that were optimized for each use case. If I want to build a governance thing that checks the case of my field names, why do I have to know how to walk JSON schema to do that? Why do I have to know how to resolve every reference and aggregate a big list of all of the field names? Why isn't there just a query that says all field names, all schema names in my API and allows me to write rules for the abstraction? If I'm doing code generation, why isn't there a simple code generation endpoint that gives me the models in code generator friendly ways? And if I'm missing extensions or things that allow the code generator to work, give me a 400 or give me some kind of error telling me what I need to add to my specification to make this use case viable. And whenever you change the API, instead of having to go into a file and change something with lines that may have second order effects you don't realize because of inheritance and other kinds of things like that, what if you just mutated the spec? What if you said add field and delete field? What if you just sent a thing that looked like an API call into the API spec and it would update things for you and you could roll it back if it wasn't what you wanted and see what other things it would impact or what other use cases it would influence. And vendors would use this API too. It would actually be a reference implementation, some WASM code that they could run that would actually make it so that we're not all reinventing our OpenAPI helper library every single time. You need the OpenAPI helper library to turn these opaque specs into the use cases. But if the use cases were the spec, then everyone can benefit from using the same kind of logic. And every gateway could have the same validation logic that worked the same way. When the specs changed, you could basically allow new kinds of mutations or new kinds of queries. But the old ones, there's no reason why that wouldn't keep working because we don't break APIs. That's what we do here. That's what we're all about. So I think basically when you start thinking about this problem, what if instead of a file it was an API, a lot of really powerful patterns emerge. Taking this one step further, we think about this as facts, which are basically the result of a mutation, and questions, which are things that you would ask using a query. So you would have a query that you would run that would render onto a human interface of some kind. We're already at the point where we have tools like Stoplight and Postman to help us build out our API specifications because they've gotten so complicated we can't do it in YAML anyway. So why not just take this to the extreme? Why not have an API for API that renders the information that matters in these different interfaces? Why not take those interfaces, mutate them whenever we need to produce new facts about our API? I know it's a radical idea, but I think it's actually closer to what we do day to day than a lot of other things we do to make the specs better. And I think this is a more sustainable route than trying to build a bunch of different API specifications that every 2 years we make a new one because things are changing so fast. So let's actually show you guys what this looks like. Spectacle is an idea we put together inside of Optic, so it already has years of validation behind it, and I think broadening it out and bringing sort of a committee around it and building the system itself could be a really powerful thing for us all to align around. So let's do a quick demo. Pause there. Cool. So here is a demo of how an API for a specification would work. The first thing that we'd have here on the left is a list of facts. We call these changelog specs at Optic, but you can call it an API for your spec or a spec as an API, whatever really helps you complete the metaphor. And what's really cool here is that it's just a ledger. It's just an event stream of every change that we have ever made to our API. So there's a simple data structure. It's easy for tools to know what these events, what these facts actually are. And they're very pure. The data model doesn't need to accommodate, can a human do this? Is this simple for users? You can just say things like they are. You can say there's a new field for this thing. Everything can have an ID, which makes it easier to build tools around. They don't need to have field names anymore. They can still have their field names, but you can use IDs to reference things, which is much easier when building graphs and building tools around these things. And what's really important, I think, is when we look at the level of abstraction that we're designing our specs at, we aren't talking about the use cases, and we're not talking about sort of the core domain. We're in this weird middle ground where we're talking about like what is human readable, writable, machine writable, like what fits all those boxes. And that ends up being pretty far from the conversations we want to actually be having about our APIs. There's no bike shedding when you're describing the pure domain. Like that's a good, I think, sort of heuristic. That may not always be true, but if we're just talking about all the things this object can be, like we will get it distilled to something that is more representative of that domain than if we have all these other human concerns baked in. So what we're actually looking at here is basically JSON schema as a changelog spec. So we add a shape called root, it's an object. We add a field called name, it's a string, and it has an ID. And as I apply more of these events, more of these facts to the ledger, you can see, just like Git has new commits that, and if you create the repo at any of those commits, it will have different file structure. It's actually changing the questions and the answers to the questions that we can ask on the right. So if we've only applied these 4 facts, what fields does an object have for this root object is going to render out those 3 field names that we set up. If we ask what fields are required, it's going to tell us these 3 are required. But if we start to include events down here, which mark them as optional, then you'll see that that field 2, which is founded year, has disappeared. So as we apply events, founded year is going to appear and disappear. We've basically created a ledger, and as you add more events to this event stream, this facts to this ledger, it changes the projections over here, the questions that we can ask and the answers that come out of them. And what's really cool about that is you can imagine these being the things that you build all of the API tooling in the space around. Not the specification, not the internal representation, but the actual reality of here's my question, here's my answer. And there's something really cool about that, which is that we can define the contract of these questions really, really specifically. We can say, for the documentation use case, there's these 20 questions. For the governance use case, there's these 20 questions. For the validation use case, there's these 6 questions. And we are going to create a reference implementation for each of them. Tools can build on top of them. And if you want to fork that and create a new version of that question, you can. But we're going to keep compatibility for all the old ones. Coming down here, here's some more questions. These are a little more complicated. These are validation questions that sort of connects a arbitrary JSON input with the current state of the spec. So we can check to see, does the spec match this object? And right now it does. There's no diffs. But if we pull this back a little bit, there's going to be some fields that we don't know about that showed up here. And as we play it forward and we start to understand more about this API change, then it's going to change whether or not this is valid or not. And if we go all the way into the future, we're going to see that it actually doesn't match anymore because something was changed to a number and it's getting a string. So you can actually use something like this to model a life cycle, to do the real design work, to merge these things effectively. And there's no reason why you can't fork these streams of facts at different points in their history and then merge them back together. And that's actually what Optic does for its workflows. When we're helping you guys design your APIs and talk about changes, we're using this basic underlying structure, which is copied from how Git manages its history and its state. So it's tried and true. It's much easier to merge streams of events than to try to merge giant YAML files that humans have written. So coming down here, there's even a set of questions you can ask here that are kind of meta questions. These are questions that take the spec into account at different points in its history. So at version n and version n+1, you can see as they start here at the same, and as I throw n+1 to include more of the facts, you can actually see that it starts to answer the questions differently. So right now, the specs are equal, but when I come all the way out here, there has been changes between this version of the spec and that version of the spec. We can see that the field was added, mascot name was added as well, founded, and all these went from being undefined to having a type. So when you look at this as a whole, you can imagine a better set of conversations that we can have as a open source and API community. What are the questions that we want to be able to ask about any kind of API? What are the facts? And the rest is just implementation. And you can imagine a structure like this, something that is compatible with new facts coming online. Not all the versions of the consumers will understand them, but you could have a fact that basically says this message type that you're using for your request, now it's being used as a WebSocket. Now it's part of a gRPC or an MMQT. Like, you can start to throw these things in all these different directions. And I think the idea that you could take a changelog spec like this full of facts and then just say, hey, we care about GraphQL now, so here are some new facts, and it doesn't break anything, is a really, really powerful idea, and something that I think our whole industry can orient itself around going forward. So how do we go from where we are now to where we want to go? Well, the first step is to start laying the foundation. What's really important here is to have those candid conversations about what can the APIs do, what do we want to be able to say about our APIs, and what are the questions we need to ask. And I think if the industry can come together and work on those two things, then building a reference implementation for this new kind of API spec that has all these advantageous properties and allow us to build sort of the workflows and the tools we've always wanted to, it can be a race car, a rocket ship that really accelerates the space. And that's what gets us excited about it. In the short term, to get there, because Optic has proven out a lot of this already, I think generally there's fairly low risk in terms of building a spec here. We would want to basically start from scratch and work with the whole community to make something that works for all the different use cases. And then we'd adopt it ourselves. I know some other companies that have sort of given me the, we'll adopt it too if this actually pans out and we can get a reference implementation. And then on the other side of that, for people who are coming over from OpenAPI and these existing tools, you can just implement the question side. You don't need to implement the facts too. If you wanted to create a way to answer the question, what are the fields in this object, or what are the endpoints in this API, you could build the same kind of resolvers that look at the event stream for an OpenAPI document and give people a really reasonable path forward to sort of go from the current tool they have into this next generation of tool, or at least for vendors to support the new version of everything to also support the older versions too. So the TLDR of this talk is we need to be treating our APIs like APIs. We need to be treating our API specs as APIs. And I think basically just more API solves everything. We've learned a lot going through this process at Optic and building a lot of these tools and talking to the community. I'm happy to keep sharing that information if anyone has questions or want to talk further about this. But more than anything else, I think now is the time to think about what's next for API specs. And I feel like we've got so many great ideas about how to build good APIs that if we just apply all of that to the API specs, we'll end up in a really cool place. So making decisions intentionally upfront and not continuing to sort of accept the consequences of this default first decision to use docs for everything is something that can be really good for the space, I think. And I'm looking forward to helping it happen however the community wants me to help it happen. Thanks so much for listening. Maybe these virtual made-up conference talks with my wall behind me will get popular, and this will be the new medium everyone talks about things, or maybe not. But it's been fun to chat with everyone anyway, and thank you to Kin, to Mike, to Matt, and to Dev for putting all these ideas in my head over the last week and a half. I'll catch you all later. Thanks so much for listening.